Welcome to this lesson where we are going to be discussing the security best practices related to Solidity smart contracts. As a smart contract developer, it is very important for you to understand how to write secure smart contracts and what are some of the processes that will ensure that your smart contract is not susceptible to attacks. Having the role of a Solidity smart contract auditor is not the same as just knowing how to write secure smart contracts. An auditor needs to have in depth information on how to write and debug Solidity contracts. In fact, they need not even know how to write. They should just be able to read the code, use the tooling, and be able to find out vulnerabilities in the smart contract. In this lesson, we are going to, in this entire module, in fact, we are going to focus on security best practices and a few lessons that will help you in terms of how to write good smart contracts. So, here are a couple of simple steps inspired by the Securium Substack, which talks about what is involved in a smart contract auditing process, right? What does it do? The smart contract auditing detects and describes security issues with some underlying, which may have some underlying vulnerabilities. What is the severity or difficulty of those vulnerabilities? What are the potential exploit scenarios associated with these vulnerabilities and some recommended fixes? The auditing report should also provide subjective insights into code quality. What is the quality of the code? Is it well documented? Is it well commented? And are there enough test cases that have been written for this particular piece of code? Now, depending on the way you want to get the audit, for example, various auditing firms deploy various types of format for the audit reports, and also depends on how much you are willing to pay to go to the depth of, you know, the auditing as a part of your code. So the scope, the depth, and the format of the audit reports will vary across auditing firms and teams, but they generally cover these similar aspects. That is, what are the underlying vulnerabilities in your contract? What could be the severity and difficulty of these vulnerabilities? And what are some potential exploit scenarios and recommended fixes? Now, as a smart contract developer, you don't necessarily need to develop a full fledged audit report. That's for auditing firms to do, which have smart contract auditors. However, if you do aspire to become a smart contract auditor, then this is a great first step for you to understand how to get going about this. So, what are the different ways in which auditing can be done? The first and the foremost is manual auditing. There is no work around to manual auditing as opposed to what you may think otherwise in terms of tooling, automation, etc. Of course, tooling automation has been built and it can be used to detect vulnerabilities, but manual auditing is almost always a process, a step in the entire process that is done by security audit firms. You can also install some auditing tools on your local system. And this is what we will be talking about a little bit in depth as to how you can install some of the auditing tools. What are the auditing tools that can be useful? And how can you understand the vulnerabilities that are produced by these auditing tools? Last but not the least, it is always recommended that before you deploy your contract to production, that you consult with a certified smart contract agency, smart contract auditing agency, in fact, sorry for the typo here. This agency will help create these very in-depth auditing reports, and they will let you know what are the vulnerabilities and some recommended fixes, what is the severity of the vulnerabilities that they have found as a part of the auditing process. Here is a website that I found which spoke about the top 10 Solidity smart contract audit tools. I'll be linking this website in the tutorial as well. You can see that there are 10 top Solidity smart contract auditing tools. Some of them are simple, like Slither. So, Slither is a tool that you can just install on your system, and then it is developed by a popular SE firm, auditing firm called Chain of Bits, and it is developed in Python which offers APIs to health security professionals. It detects vulnerabilities with a very low false positive rate, and there is a average execution time that is less than 1 second per contract. It's pretty fast. I've used Slither myself. However, there is one of the very basic tools. So I recommend to use Slither as a first step, but it may sometimes miss some vulnerabilities that could have a bigger impact on your smart contract. Now, there are a couple of other tools as well. As you can see in the article, there is Securify, which is in partnership with Ethereum Foundation and Chain Security. This is, again, it can discover the vulnerabilities like transaction order dependence, right to arbitrary storage location, shadow state variable, unrestricted self-destruct, right? One of the popular problems that we face, uninitialized state variable, again, unnecessary storage here, uninitialized storage, reentrancy attacks, unexpected ether balance, etc. So you can go through this at your leisure, where you can find Mithril is again one of the famous tools in the industry that I have been hearing of quite recently. So I would suggest to try this out. And then there are also fuzzers, right? Fuzzers are also like you have Echidna, you have this contract fuzzers, which use fuzzing as the technique to find out vulnerabilities in the contracts, right? This technique is basically what this involves is you try to give various inputs and various different types of inputs to trigger a strange behavior in a contract. So think of this more of like a stress testing that you're doing, right? And this is something that is also very important to figure out how your contract will react under certain scenarios, right? So there are a lot of fuzzing tools as well. And then, as you might be familiar with Remix IDE is a browser-based IDE where which we largely use to write our smart contracts. This also has some inbuilt plugins like Solidity Static Analysis and Mythics plugin that can help you determine some vulnerabilities, right? Like transaction origin vulnerabilities, reentrancy attacks, inline assembly use, timestamp, dangerous low-level calls, block hash usage, self-destruct, etc. Right? So, yeah, this is pretty much it. What I wanted to sort of introduce the basics of smart contract security in order to avoid any kind of drastic attacks. There are a lot of best practices that you need to follow while writing the smart contracts. And a large part of this entire module and the upcoming lessons will be associated with best practices. And then also some insights into what are the kind of tools that you can use to detect vulnerabilities in your contract.